Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I will be revisiting the grains exercise that I did last week. Here's my solution that I submitted last time, and if you want to see how I got to this solution, there's a link in the description of that video or right up here in the corner, and again at the end if you want to go and watch that. But when I finished this and got it all ready and uploaded to YouTube, I submitted it and went to choose the next exercise, and I noticed something. I've pointed out before that the exercises on this screen have tags. And sometimes those tags give you a hint about either how to solve the problem or really what the authors of this exercise are really looking for you to learn. What do they want you to learn? What do they want you to do? And I noticed this little tag here, bitwise operations. Well, I didn't use any bitwise operations. So even though I made the test pass and I think I have a really good solution here, it's not really what they wanted us to do. So I thought I would take a second pass at this and use the approach that they really intended for me to use, and use some bitwise operations. So that's what I'm going to do today. So once again, to describe what this problem is, it's in the form of this story here: a wise servant who saved the life of a prince, and the king promised to pay whatever the servant could dream up. And knowing that this king loved chess, the servant told the king he would like to have grains of wheat. 1 grain on the first square of a chessboard, 2 grains on the next, 4 on the third, and so on. And a chessboard is an 8x8 grid, so there are a total of 64 squares on a chessboard. And so I needed to write code that showed how many grains were on each square, and then the total number of grains on the board. All right, so let's go ahead and dive into this second approach. I've simply cleared out what I had here, and I've gone back and I've commented or uncommented the skip on all the tests but the first one. So I'm just going to go ahead and dive right in. Of course, this test will fail because I need to define the square method once again, and this is a class method. So I need to get into the class level space and define square. And it's going to complain, of course, again, due to the arity. So I'll do that again. I need to accept an argument that this time I think I'm just going to call it index. I know I went into detail last time about why I didn't think it should be index, but I'm going to call it index this time. And I'll show you why and what I intend to do with that here in a second. Of course, we're returning nil, but we should be returning 1, so I'll hard code that again. And so really, this is going to be almost identical for the first couple of tests. This will fail because I'm returning 1 and it expects 2. So I will simply switch this now to return index, that which return what I was passed. And I'll use the third test to actually force me to do this. Right, so again, that test failed because I'm returning 3 now instead of 4. So I see now that the tests have driven me to see that it's just sort of happenstance and the way the math works, that the first 2 squares, the square name and or the square count and the number returned are the same. The number of grains are the same, but that falls apart here. So I need to actually do something here. So taking that clue of bitwise operations, I realize that I'm dealing with a sort of a base 2 system here. What I did before was I did 1 to the power, or 2 to the power of whatever square I was on, the index 0, 1, 2. And that accomplished sort of the same thing. It gave me the number for that particular square. But if we do something else here, I want you to notice this. So in Ruby, the way you write a binary number is 0b. And so the first square, this is the rightmost digit, if we're just looking at that square, then this is the number 1, and that's how many grains of wheat are in the very first square. But if I shift that once to the left, now I have 2. So 10 in binary is 2. And then if I keep moving each square, so the next square will have 4. See how that works? So what I need to do is take this 1 and shift it according to the index of the square. Now, you know, we're passing in a 1, sort of a 1-based array, you know, the first square, but the index of the first square is actually going to be 0. So I'm going to do what I started to do in the other exercise. I'm just going to subtract 1 from this to arrive at the actual index for that square, counting from 0. And now I can, let's see, is it left shift by index? And this will be returned. And of course, it's just going to be an integer. I'm just right here. I'm just defining it as a binary, but it will return, you know, as an integer, and this equal should match up. If I did it the right direction, that will work. So in Ruby, this these two less than signs together here is the bitwise shift when it comes to binary math. Now, you may recognize this also as the what I usually call the shovel. So if you have an array and you can, you know, shovel a new value into it, you know, you'll wind up with an array with that value in it. But in this case, when you call this method, because remember, in Ruby, this is just syntactic sugar for calling a method. When you call the method, you know, left like that, that's the bitwise shift, left shift operator. And so what it'll do is it will move this 1 that's in the farthest right place right now. It'll shift it over by whatever the value of index is. Well, for the first test, we're passing in a 1 for the first square. Well, the index of the first square is actually 0, so we're giving it a 0, so we're going to left shift 0 positions. And this is actually binary 1, so we will return 1. When I pass in a 2 for the next square here for this test, then index will be 1. And if I shift this over 1, then it's going to return that, which is binary 2. See how that works? So this, I think, actually will get us all the way down until we have to check for bad input, out of range input. 32. And then finally 64. All right, that works for now. Let's go ahead and raise an argument error here, which we're not doing yet. So I'm going to do it right here. No, hang on. Raise argument error if index is less than 1. Yeah, negative. That will work too. And then the last thing is I have to handle the opposite case if it's greater than 64, meaning we're you know, we're off the board on the other end, or index is greater than 64. All right. And then finally, we have to implement total. And I'm going to do something a little different here than I did last time. Of course, this won't work because we haven't defined it yet. So let's see, total. And what I said, if you watched the other video, you probably saw like a comment. I just put a caption on the screen saying that, you know, in this case, this value total is never going to change. So there's really no reason to calculate it. We can just define it here and return it. And so let's the cleanest way I know to do that here is just to define our number here. And here I'll do it on several lines so that and then bring them together so that I can see what I'm doing more easily. Because this is a lot of ones to write. I need 64. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm just going to create the chessboard here. I'm going to put 8 rows, and let's just bring them together. All right, that should be the total. Oh no, I have one too many rows. Let's undo one and whoops, and get rid of this row. I pasted 8 times. I should have pasted 7 times. Okay, so everything's working here, and I want to go ahead and do some refactoring just like I did before. And I think the first thing I'm going to do here is I hate how this looks. And so what I want to do is I think it'll be a little easier to read this and understand this if I define an array here that represents my chessboard. Is that the right amount? 1, 2, 3, 4, 5, 6, 7, 8. All right, there's our chessboard as an array of strings. And let's see. Can I just 2i that array of strings? No. Can I join it and 2i it? Wait a second. Oh, yeah. Hang on. Join 2i. I have to give it a base of 2. Can I avoid the join if I do that? No, I always need to do that. Okay, that's fine. But now, total has no business defining this. So I'm going to extract this to a constant that I'm going to call chessboard. And now I can so this is okay. I'm okay with this being 1 because it's the very first, or maybe I can extract that like I did before to min index coming in. Min index equals 1. And max index, which can actually be chessboard.length. And really, let's see. I'm going to pull this all out into validate method. Make it private. And again, I've talked about this. Whoops, wait a second. Okay. This exclamation point at the end of this method name, we'll call it a bang. and it indicates something dangerous. And a linter will, like Rubocop or something, will complain about this, and it'll tell you that that you've got an unsafe method when there's no safe method. And well, we're raising an argument error here. And so I like the warning that something is going to happen, that there's some consequence. So it's either a side effect that's unexpected, or in this case, hey, this might raise an error, an argument error, or raise an exception. So you want to know that. We could take the time to implement a safe version of this that, instead of raising an argument error, would accumulate errors on an object that we could then check. And in fact, man, oh man, I think I want to make this an instance of my chessboard, or actually, I think I want it to be a square class, because it represents one square, and this particular square, a square will have an index. And so I need to define initialize, and I need to set that instance variable. But I also want to validate right here. I want to validate this index. Or actually, I can do it here and not pass index. So let me move this whole thing down to my new class square. I'm going to move min index and max index down as well, because square is the only code that really cares about it, is my square class. And here I'm going to new up an instance of a square, giving it my index, and call square on it. Or let's call it, I'm going to call it value, actually. Or number of grains. Or grains. Let's call it grains. And grains will return okay, so here's another opportunity. Let's just do this real quick. Let's see if this works. No, undefined method minus for a nil class here on line 36. So I've got an adder reader index. Oh, I see. I would have to do that. But this sort of thing here where I'm normalizing my grains, I really want to do that on the way in. So let's subtract it there, and then I need to change min index to 0, chessboard length -1 to get the actual index of the final element. Okay. All right. Here I could also extract a normalize method, because initialize really has no business knowing that detail of how I normalize my input. But what I have to do is subtract 1 from it. It could be something else. I could force it into an integer to make sure I was passed an integer, or if somebody passed a string, to do my best to make sure I had an integer. You've seen me do that in some other exercises, but for now I think I'll just leave it like that, and then I'll validate it here. And then the last thing I really see here is that this 0b1, let's see, oh, here. It's not the last thing I see. See, this I can extract to, I'm going to call this base because I'm working in base 2. All right. The only other thing I see here is I've got this magic number sitting here. You know, I think I'm going to leave this explicitly here because it communicates to me what I'm doing. I've got a 1 and I'm shifting it according to the index of myself. And that's going to return the grain count. So let's look at this. Let's read this from the top down. So I have these 2 class level methods. So total just takes my chessboard here, joins it where it joins it together and treats it as a binary number. So really this is the first place, second, third, fourth, all the way up to the 64th square up here, because these get joined together into a great big binary number that gives us the total value. So we join them together, convert it to an integer, and then a base 2 integer, and that gives us our value for the total. Square initializes a new square class, a new square object with our index and asks for the grains. When we initialize it, we normalize the index, which involves subtracting 1. And we validate it, which, okay, here we can do a little bit more work here. Raise an argument error if index is less than the minimum index or the index is greater than the maximum index. We could call that, let's see, out of range. If it's out of range, so we could call it, again, too small or too low. What do you think? Too small? And too large? That's what out of range means. Is it too small, or it's too small, or it's too large? Our index. Okay, so this, I think, is it. And this might be a little bit more what they were expecting us to do and learn about. We did some bitwise math here, and a bitwise operation. You know, this total is not really a bitwise operation, but it is sort of binary math. They're using the binary representation to get what we want. Yeah. I don't know. I'm going to go ahead and submit this as a second answer. You know, so go ahead and go back and watch the other one if you haven't seen it yet. Let me know which of these you think is better, or clear solution to the problem. I mean, you know, clearly they wanted us to do something with learn something about bitwise operations, and so this approach follows that. If there's something else you see that would maybe exploit bitwise operations a little bit more that could teach us something or make it more readable or more clear or more performant, maybe drop a comment below. Maybe post your own video and link to it in this video so I can see what you did, or link to your solution on exorcism.io. Anyway, cool. Well, thanks for watching again. Thanks for watching this far. Hope you liked the video. I hope it was helpful. I hope you learned something. If you did, please go ahead and click that like button below and subscribe and hit the little bell if you want to be notified when I post a new video. And also, you be sure to check out my tactical refactoring course linked in the description below. All right, have a great day, and I will see you in the next video.